Okay, so let's begin. Today we'll be touching API testing. Actually, we'll not go in depth, but we'll just briefly go through it and then see how we can test our APIs in using Postman. But what we're going to be doing here is we'll write our first test. We've already learned about Postman variables, but then we'll learn how we can set variables in our test. And then maybe we can see how we can extract data from response. And then we'll see if we can touch the collection runner. Then from there, the rest of the items on the list, you will go and then try to learn it on your own, because you already have the basic knowledge of the Postman, because we've got a lot to do, so we don't want to waste much time on this. You go and learn about, if you don't touch collection runner, you go and learn about the collection runner, the request execution order, Postman monitors, Newman, HTML report with Newman, and then CI/CD overview, or how you can integrate Postman with your CI/CD workflow and all of that. So first of all, let's see how we can write our first test. So open up Postman. I already have this the task manager we're testing the other time. But what I want to do is, I think cool. Yes, I think our server is back. So let's see if it's actually working. Okay, it is. So we use this to test. Just copy this URL. Bring it to Postman. I think we should delete this request. Delete this one. Delete this as well. So add a new request. They will call it register. And it's a post request, like so. Let's paste in our URL. That's /auth/register. So I think /auth. Let's use the session auth, because we have the token authentication and session authentication in our app. So we use the session auth. Okay, so now let's try to register a user. Username of let's make it a random username. Random username and password. Random password. So random password, like so. I was forgetting a comma. Okay, so now let's try to register this user and see if our endpoint is working. So let's send this request. It's taking a little bit longer. Okay, user registration successful, and then errors no. Okay, so when we've registered the user, Let's add one more request. And this request should be get requests. Let's tasks. Let's select yes a collection of task manager, and then the name should be tasks. Yes. Let's save it. Save. Okay. So now let's open up our headers, and as you can see, this cookie is automatically added to our headers. So if you make a request now, we're using this cookie. Once a user is registered, you can see in the headers that the cookie is added, and the whole of this collection, this cookie will be added in the headers. Look at the cookie here, the KCTM session. That is the name of our cookie, KCTM session. So if we make a request, we already have our cookie here. So we make this request. Oops, we're having unauthorized. Why is this so? Slash tasks. Okay, but that's not the reason why we're here. Let's just forget about that for now. Let's write tests. Let's not waste time for. So if you want to write any test, you look at this bar here. You click on the test tab, and you have an empty window. And on your right hand side, you have snippets. These snippets here can guide you on how to write your test. You can set a global variable. You can set a collection variable. You can clear an environmental variable, and all of that. You can send a request, status code of 200. Okay, so now we want to test that our registration route is working correctly. Now, if you send a request, we're expecting a status code of 200. I mean, sorry, 201, which means created. Okay, so let's now, you can write that manually, but you can come here and then check this snippet. You can check the content type header. You can check response time is less than. Yeah, you can check. Okay, this is, let me bring this down a bit. You can check, you can send a request. The response body contains string, response headers, and then status code for successful post request. So we want to use this one. So let's click on this one. And you can clearly see our test here. You can see the successful post request and this. Then we want to check if our response contains one of these, the status code of 201 or 202. So let's make this request once more. And let's see if our test will pass. Okay. As you can see, test results in our response body, test result, successful post request. You can see. And if you open our terminal, our console, you can see here, content type application JSON, Postman token, connection keep alive cookie. And look at our cookie here, the request body. You can see the password and the username here. Okay, so now let's use this password and username to log in, or we can just do something like okay, you know what, let's head over to GitHub and check. GitHub slash this. Let's check something here. KodeCamp 3. What's here actually? I think I extracted this. Task manager. Now source, we have our index. Let's check the index file. Tasks, token auth, and then session auth. Okay, and the reason why we're getting unauthorized because we're using the token authentication to verify users to handle our authorization. So what we do here is in our registration, we say token auth, like so. Now let's send this request again. Okay, it's successful. And the headers, we're still having the cookie is still there. Token auth. Body, yes, we have our token. So copy this token, like so. And then we edit this, then we add our token, initial value, we add it to our current value, and then we'll make it a secret, like so. Okay, so now let's come back to this place and then add another request. You can click here and then add a request and name it login. And in this login, we can actually select this and then select login. Then make this a post request with a body of let's quickly check our terminal. It's a body of okay, request body of this, the username is this, body post request, raw JSON. Okay, let's log in with a username, this username, and then password of this very password that we have here. This one. Okay, let's send this request and see what we've got. Okay, we have a token. We already had a token. Our login in, the token has changed. Let's copy this one and then replace the one we already have. Now let's make a GET request. The token will come to auth here and then bearer token. And then we see token, like so. So let's make this GET request. Invalid value title query. Tasks, no errors, types field, message invalid value, location query, and all of that slash tasks. This is a GET request. So why are we getting this error? Okay, that's by the way. Okay, so now let's move to our tests. We've seen how we got this 201 and 202. Let's make this request again. We're using random username and password. And in our tests, where is it? Response body. Response body 202 view. Okay, test results. We have successful post request, and that's the name of our test. And we can even do something like console.log PM response, like this. Then let's send the request again. Let's open our terminal. And then we've seen our response. The response here, the status is created. The code is 201. It says it was created, code 201. And we have headers, a lot of headers here, the data and the value. We have content length 237 and a lot of headers. We have the cookie here is 0, have the string type buffer data 237, which is the content length we got earlier, response time, and then the response size. Okay, so we have an ID. We can do something like, we can add another test like PM, expect PM, that is Postman response. Response, not request, response. But what else do we have? Status to, sorry, to equal, I think, yes, equal created. And we use a regex. So we avoid this uppercase. Created, the first letter is uppercase. So we use this. Let's send the request once more and see if our test is passing. Okay, now the test is failing. And why is it failing? Successful post request assume expressed created equal to created. Okay, let's just make it created. Okay, so now our test is passing. Passed or skipped, failed, none. All the tests passed. And we can say we can do something like response equal to PM response. Then we can do something like, or you say res instead of response, res. Then you can do something like res dot code and then res status. Send request. Great. So our test is still passing. You can add another test like PM expect res. We had a lot of things. Response size. Response size. It should be less than 2, less than 300. So let's run this test. Okay, our test is still passing. Okay, we're testing. We're making sure that our response code is 201 or 200. Then we're testing also we're checking if the response status is created, and then the response size is less than 300. Okay, if you change this to 250, or let's say 200, and then try it again, try it once more. And we'll see that expected 231, but to be below 200. Our response size is 231 and not 200. 200 is less than, it's not, it's less than 231. We say the response size should be less than 200 and it's greater than 200. So if we change it to 300, our test will pass once more. And if you don't want to test this one, you can just remove these ones. Just copy the whole thing, like so. Paste it down here. Then you see a successful post request, successful response code, and then successful response status, like this. Then you remove this one. This one. Come up here, remove this and this. Then save your test. Run it again. And now we have two tests. All of them are passing successful response code and the successful response status. And then we have a runner here. We don't have much tests, but what this runner normally does is we'll drag our task manager and then paste it in here. We have 3 requests. And then if you run this running request, as you can see, we have 2 tests passed here. And here say the second request, no test found. And then the third request, empty request, URL request could not be sent due to an error. Check console. So what this runner does is we automate our test. And when we run it, our test will run from beginning to end. And then there's also a monitor here. You create a monitor, then you can monitor your test, the monitor name, select file, week, and everything. You automate your test so that you integrate it with your CI/CD workflow. And that's actually awesome. But I think we're not going to be discussing about that. I wanted to show you how you can run tests in your Postman. And earlier when we logged this to the console, we saw ID, code, status, headers. You can even check the headers, the content of the headers. You must make sure that the headers is returning an authorization token and all of these things. You can check everything, anything, any request you want to make. Okay, and I think that's all for Postman. You can go ahead and explore the rest of the options on your own. It's not something hard, how you can run tests. And later we'll still be running unit tests to test our APIs. But for Postman, I think this is all. Postman variables, and let's just touch a little bit of variables. We have test, register, test. Here, come down to your snippets, check how we can add an environmental variable, select a collection, set a collection variable like so. Then you set, let's say token. Then you want to set it to, I'm getting back a token here. And I think I was supposed to be getting back a token. Request body. Response headers. Response body. Yes, and in our response body, then we can do something like response. We log our So log res body. That's our response body. And then we'll come down here, our console. Let's send this request once more, this register request. Okay, so now we'll scroll down here. Okay, the response body is undefined. I think it should be some request headers, response headers. Response body. Okay, let me just set something like token, and then we'll say some token, like so. Let's not waste time extracting the token there. You can send this like this. And then check your environmental variables, edit. Let's take it to default, change type. We still have our token. And since it's in our test, it will not appear here. But our test, we automatically use it to run test. Then you can do something like PM collection variable set token, and then you can see set a collection variable. You can get a collection variable. Say something like token, like this. And let's see if we've got something. Oops, an error. I think okay, so we have some token. Okay, it's supposed to be some token, but also some token. And then we're accessing it here. Collection variable get token, and the value is some token here. And then look at the value down here. So this is how to set environmental variables. This is how you can set an environmental variable while making this request, and then you can come to your get tasks here, and then get the environmental variable, and then set it in and use it in another test. So that's mainly the use of environment variables in testing and running all of those things. So if you don't want to test your API using Supertest and Jest and Mocha, all of that, what you will do is you use Postman. But I prefer using JavaScript with Mocha and test and Jest, all of that. Okay, that is it for API testing. Postman variables, first test, extracting data from response, and then you learn about the collection runner, as I've demonstrated a little bit of it and the rest. Okay, so the next on our list, the main topic of today is real-time applications with WebSocket. Okay, so I think I tried to have some notes here. KodeCamp Task Manager here. We have WebSocket. We have docs. Okay, so I have some notes for us. I'm trying to push this to GitHub. And I think it's taking time. I don't know if it's due to network problem or you know what? Let's just fasten up the process. Let's do something like this. Okay, KodeCamp. So let's copy this to the project directory. I think I should copy to. Okay, we have it here. So let's just come down here and then open this. Okay, so we have some docs in here and we'll quickly go through it. I don't think I will be pushing it to GitHub. We'll quickly go through it. And the first thing on our list here is WebSockets. What are WebSockets? How WebSockets work? When to use WebSockets? WebSockets with HTTP, and then we build a minimalist real-time chat application. But first of all, we have to understand what WebSockets are, how WebSockets work, when to use WebSockets, and then WebSockets with HTTP. So come down here. So what are WebSockets? WebSockets are a communication protocol that enables real-time two-way communication between a client, usually a web browser, and a server over a single long-lived connection. This is in contrast to the traditional HTTP request response model, where the client sends a request to the server and the server responds. But the connection is short-lived and the server cannot initiate communication with the client. You know, in a client-server architecture, the client will send a request to the server and the server will send back a response. But that's a different case in WebSockets. Okay, so here are the key components and aspects of WebSockets. There is number one is a protocol. WebSockets uses WebSocket protocol, which is a standard protocol defined in RFC 6455. These are the protocols that define the web standard and how all these things communicate. This protocol operates over a single TCP connection and is designed to be lightweight, efficient, and low latency. Okay. Now you may be asking what latency is. I did something light on latency here. This is actually latency refers to the delay or the amount of time it takes for data to travel from the source to its destination in a computer network or system. It is typically measured in milliseconds and represent the time it takes for a signal, a packet, or request to travel from the sender to the receiver and then receive a response. Okay. So that was latency is the time it takes if you send a request. It is the time it takes for that request to reach the server and for the server to process the request and then return a response. That is actually latency. So if you understand what latency is, This first, the protocol here says WebSocket, they operate over a single TCP connection is designed to be lightweight, efficient, and low latency. The latency is not high. The time it takes for the client to communicate to the server is, it takes a little time and not much time as it takes HTTP requests. And we have the second item on this, the handshake. The process begins with a handshake between the client and the server. So the client sends the HTTP request with an upgrade header to indicate that it wants to establish a WebSocket connection. Okay, so these are the things we need to understand about WebSockets. What the client does is it sends an HTTP request with an upgrade header to indicate that it wants to establish an upgrade. Notice this upgrade here. The header, it includes this upgrade header to indicate that it wants to establish a WebSocket connection. If the server supports, if the server they are sending the request to, the client is sending the request to support WebSocket, it responds with the success message and the connection is upgraded to a WebSocket connection. And this is great because it enables us to understand how WebSocket work. So the client will send, initially the client will send an HTTP request to the server with the upgrade header. The request will include the upgrade header, telling the server that, okay, what I really want to initiate is WS request and not HTTP request. So if you support WS, send me a response, a success message, and then upgrade this connection to WS. Okay, so now, third item on the list is full duplex communication. Once the WebSocket connection is established, both the client and the server can send data to each other at any time without the need for a new HTTP request / response cycle. Can you hear that? This allows for full duplex communication, meaning that data can be sent in both directions simultaneously. And this one great advantage with WebSockets. Once the server supports WS, it will respond with a success message, and then the connection will be upgraded to WS and not HTTPS or HTTP. The connection will be upgraded to WS or WSS, that is WebSocket or WebSocket secured, like HTTP and HTTP secured. So in WebSockets, we have WebSocket and WebSocket secured. That is WS and WSS. Okay, so once the server supports, if the server supports WS, the connection will be automatically upgraded to WS from HTTP to WS. And then subsequent requests will be sent to the server, not actually the server, but subsequent requests will be sent to and fro without the need for a new HTTP request or response cycle, because the connection is established and it's a keep alive connection. So real-time updates, the fourth item. WebSockets are commonly used in applications that require real-time updates, such as chat applications, online gaming, financial dashboards, and collaborative tools. Instead of calling the server at regular intervals for updates, the server can push data to the client as soon as it's available. Wow, that's great. Then low latency. WebSockets are well suited for scenarios where low latency is crucial because they eliminate the overhead of creating a new HTTP connection for each interaction. This makes them ideal for applications that were quick. Applications where quick response times are essential. Then we have WebSockets API. To use WebSockets in web applications, you can utilize the WebSocket API provided on most web browsers. This API allows you to create WebSocket connections in JavaScript and define event handlers for messages received from the server. Then keep alive. The keep alive connection I mentioned earlier. WebSocket connections are long-lived and they include a built-in keep alive mechanism to ensure that the connection remains open. If either the client or server detect that the connection is idle or has been lost, they can initiate a close handshake, and we'll see that in a minute. So we have 7 items. We have the protocol, handshake, full duplex connection, real-time update, low latency, and then In summary, in summary and review, what we've said is WebSockets provide a way to establish persistent, full duplex, low latency communication between clients and servers, making them a powerful tool for building real-time web applications. They have become an integral part of modern web development, enabling interactive and engaging user experiences. If you have any more questions or need, okay, you can feel free to ask me. Just included that so as not to leave it out, because I know this is kind of confusing. So if you have any questions or clarifications, you can go ahead and ask. I'm always here to answer you. Okay, so how do WebSockets work? This is the main question here. How do they work? Okay, so we have some items here that describes how WebSockets work. The WebSocket communication begins with a handshake process. It starts as an HTTP request. This is the most important thing to understand. A WebSocket request starts as an HTTP request from the client to the server, typically initiated by a JavaScript client running in a web browser. So this initial HTTP request is called the WebSocket handshake request. Yes. Okay, let's assume I don't know you. We're just meeting for the first time and I decide to shake you. So after shaking you, I say, oh, what's your name? You tell me your name. And oh, so this is who you are, this is where you're from. And then we'll get to know ourselves. So next time when we meet, we don't have to ask ourselves, how are you? What's your name? Where are you coming from? I can actually ask you, how are you? But I don't have to ask you, where are you from? What do you do? Because we already know ourselves. So when next we meet, we just further our communication without introducing ourselves. So this is what is happening. The initial request is an HTTP request, and it's called the handshake. This initial request is the WebSocket handshake request. So once the handshake is initiated, what next? Upgrade request. In the WebSocket handshake request, the client includes an upgrade header with a value WebSocket to indicate that it wants to establish a WebSocket connection. Additionally, the client sends a unique key as part of the request. Yes. So the server response now, what happens after sending this header? What is the server response? When the server receives this WebSocket handshake request, it checks if it supports WebSocket. If it does, the server responds with an HTTP 101 status code switching protocols. It will switch the protocols, the 101 HTTP status code, indicating that the protocol is being switched from HTTP to WebSocket. So the server also generates a unique response key based on the client's key and send it back to the client. Understand this? The server also generates a unique response key based on the client's key and send it back to the client. And then WebSocket connection takes place. Once the client receives the server's response and confirms that it's an upgrade to the WebSocket protocol, it establishes the WebSocket connection. This connection is now full duplex, allowing both the client and server to send data to each other at any time without reinitiating any connection. You can send data to the server at any time. The server will send data to the client at any time. So that's the reason why if you are connected to the same WS, I will post a message, the server will forward it to you immediately, and you post a message to forward it to me immediately without initiating any connection. And that is instantaneous, because once you send a message, the message is being sent, is being broadcasted immediately. Okay, the data transfer. After the WebSocket connection, there's a full duplex, allowing both client and server to send data to each other at any time. So what about the data transfer? After that, after the WebSocket connection is established, data can be sent in both directions. Each message sent over the WebSocket connection is framed by a header that includes information about the message length and type. This framing ensures that messages can be segmented and reassembled correctly. In networking, there's what you call packet switching. A packet is kind of messages sent that are being deassembled, and then these messages are deassembled and sent over the web. So when they arrive to the destination, there's what you call packet switching. These messages will be reassembled in order and then decrypted to, after reaching the destination, it will be reassembled and then decrypted so that the receiver will get the meaning of the message. Once you send the message, it's encrypted, and then they are disassembled in order to get to the destination. So when they get there and packet switching takes place, they are reassembled and then decrypted. So that's actually what's happening. Each message sent over the WebSocket connection is framed by a header that includes information about the message length and type. This framing ensures that messages can be segmented and reassembled correctly. And events and callbacks. In web applications, JavaScript code can use the WebSocket API to interact with the WebSocket connection. So developers can set up event listeners to handle incoming messages or errors and define callback functions to send data to the server. And we'll look at that in a minute. A keep alive connection. WebSocket connections are long-lived, but they include a keep alive mechanism to ensure that the connection remains open. Periodic ping and pong messages are sent between the client and the server to check if the connection is still active. If either side detects that the connection is idle or has been lost, they can initiate a close handshake to gracefully terminate the connection. That's great. So closing the connection. When either the client or server decide to close the WebSocket connection, they initiate a close handshake. This handshake involves sending a close frame with a specific status code and a reason phrase. Once both sides have acknowledged the close frame, the connection is fully closed. Security and all of that. When to use WebSockets, I think WebSocket with HTTP. We've discussed this. Request response model, HTTP are stateless, the latency is high, and the request response model in HTTP. But then in WebSocket, the latency is low, and they support full duplex communication, real-time updates, efficient for continuous streaming, connection overhead, and protocol, all of that. And then let's briefly look at when to use WebSockets. We're not going to explain, we just mentioned real-time updates, online gaming, live streaming, financial applications, collaborative tools, notification and alerts, monitoring and dashboards, online auctions and bidding, customer support chats, IoT applications, multiplayer online experiences. That's great. So let's talk about this. How do, okay, we've talked about when to use WebSockets and all of that. We'll talk about everything. So in here, I think I have this folder is empty. This WebSocket folder is empty. So what we will do is we'll quickly create a source folder. And our list, we've discussed what WebSockets are, how WebSockets work, when to use them, and then WebSocket with HTTP. The HTTP, the latency is a bit high, and in WebSocket, it's low. WebSocket supports full duplex communications, and then HTTP, it's client server, request response, and all of that. So now we try to practicalize and build a minimalist real-time chat application with WebSocket. So first of all, this will create a folder of, let's delete this. It creates client folder, then the server folder. In our server, we have another folder of source. Then we'll open up our terminal. Let's bring it down a little bit. Wait, and then we'll see cd server, cd server like so. We are in our server. So first of all, say npm init-y. We have an empty JSON, a package JSON file. You can come here and say type is module like this. And what we need to install is nodemon npm Node one. Development dependency. Okay, it's installed without with zero vulnerabilities, and we installed WebSockets as both development and production dependency. npm I ws. Okay, so we've installed WS as our dependency and Node as our development dependency. So what we want to do now is create an index.js file in our server, in our source folder, index.js, like so. And inside of our index.js file, we want to import from WS. We want to import WebSockets, WebSockets server, like this. And in our package.json, we add a start script. We're not using this in production, we say start // index.js, and this will be node source index.js. And let's come back. And then first of all, we will create our server, and then we make sure it's running. So what we want to do is say WebSocket server is equal to new WebSocket server, like this. We need to take an object with port of, let's say 3000 or 8080, comma, a callback function, then we log server running on port 8080. Now we initiate a connection. We say WebSocket server on connection, passing a callback, and then a client that is connected to our application. If there's any error, if there's any error on connection, what we want to say is error console.error, like this. So let's go ahead and start our server. npm run start. Okay, server running on port 8080. That's great. That's great. Okay, so now what we want to do is, if there's any incoming message, we want to log the message to the console. We will say if there's an incoming message from any client, this, we'll grab the message. If there's an incoming message, we want to grab the message here and then log it to the console, like this. Okay, but before we go ahead to complete our server, let's build our client and then see what we've got. Okay, so if the connection is idle or it has closed, we want to successfully close our connection, the callback, the callback of and we log connection closed. I think this is okay. What's happening here? Reference error, the way is not defined. Cut this and then bring it in here like this. Okay, so our server is running. So what's going on here is we've established a connection, and every time a client connects to our server, as that is anytime there's an incoming message or an incoming anything at all, let's say message or a request, we simply log it here. Or in this case, we're using message because on the connection, if there's an error, we log the error. Or if there's no error, we take the client that just connected. If the client sends a message, we receive the message and then log it here. But first of all, before we continue, let's go back to our client and then create an index HTML file. So WebSocket. Okay, so we'll just have an input, a button of send, you say placeholder, type your message. Then we'll have a dive. Then we need to associate some IDs with these elements in order to gain control over them. So what we will do here, let's say this is an ID of let's say message, contain our message there. And here is message, sorry, ID of message button, and here is an ID of say chat input. So I think chat input is okay. Yeah, chat input, message button, and then message dive. Okay, then in the body down here we have a script. We'll write our JavaScript like so. And then first of all, we get access to our server is running on SQL server equal to new web socket, and instead of using HTTP slash localhost, this is not HTTP, this is web socket. So what we do is we say ws // local host 8080 like this. Okay, so now we get access to our chat input. or we can say, let's change it to a message. We can come here and this is chat input equal to document query selector of message. And we also need to get access to a chat button. So const chat button is equal to document query selector message button to const chat dive is equal to document query selector chat dive, like so. Okay, so we've accessed the three elements we have. So what do we want to do now? We want to add an embed listener to this message input. We see server add event listener to it should be a click event. Let's leave this first. Let's add a click event to the button. Chat button add event listener click, and the callback function like this. Let me see. Const message is equal to chat input. We want to get access to the value. Chat input value. And then we say server send message. We'll click the button. And then after sending it, we want to clear the input. Chat input value is equal to an empty string. Okay, so let's see how this works. Let's go live with our HTML. Go live. Test message send. Come down here. Okay. So we're not getting anything. Okay. Let's implement our server functionality. We say server on message, the callback of event. And if there's an error, we say event. Let's go back, we're taking an event, and then we say log event like this. Chat, message with chat input value. The message is the chat input. We want to get access to the value. ID message, and the ID is message. Okay. I think we're getting an error. Yes. Okay, the URL local space is invalid. Fail to construct WebSocket. The URL ws// this is invalid. Okay. It's invalid because ws colon and then // yes, it's supposed to be like this. Let me say test message, send, our console. Okay, so we have a buffer. The buffer is text message. I think 74 is, this is 74 in ASCII is T or so, something like that. So we have a buffer, send message. Then let's check in our server. Well, simply log in our message in message dot to string, like so. So let's send the message once more. Message. Let's check. Okay, and we have our message on the console. So as you can see, there's no need for HTTP connection. Once I will see that in a minute. We'll try to connect two clients to this server and then see how we can wire out the functionality. But for now, what we want to do on the client side is, after sending the message, we want to add it to this dive because you are the sender of this message. And after sending it, we want to say, okay, chat dive dot inner HTML plus equal to, and then we say a p tag of a p tag of message. And then we can do something like, let's come down here. We've got our event. So our event, we want to convert it to text. So we event, say event data text, like so, it's text, but then we're taking a callback of text. We see chat dive dot inner HTML plus equal to this. Okay, let's say this. This like this. Okay, and if there's an error, we handle the error. Let's see, that's patch. The callback function error. You see console dot error. You can see error converting blob text. As you can see, look in the console, once the server detects an idle connection or a closed connection, you see connection closed. What we're getting is connection closed. So let's initiate connection once more. Test. Can we read professor now reading inner HTML? And why is that so? Chat dive, query selector, chat dive. Okay, it's chat. Okay, let's make this a chat dive. Chat dive, like so. We actually got our message test, but the error is on the client side. And then we refreshed our client and the connection closed. Can you see? And then our message appeared, test dive. Let's send message once more. Test. Reading inner HTML. Query selector. Chat dive. Round spelling. Connection closed. As you can see, we have our message here. So what I want to do is to copy this. Oops. Copy this. No, that's not what I want. Open a new window, a new tab, paste it in, hit enter. Then you come here and see test, send, test 2, send again. And then come here, open this. Refresh this, have test. Test. Okay. Test 2. Let's change this here to 500. Test. Okay. The reason why I think we're done with our clients here, and the reason why we're not getting that is on the server. The server is not actually sending back anything. We're just logging the message to string. Okay, so now let's implement our server how to broadcast this message that we're sending from the client. Once a single client sends a message, we want to broadcast it to the remaining of the client. Okay, so how do we go about doing this? So inside of this message, let's write a broadcast function. Let's say function broadcast. And then here we have, let's create a simple database of this const client is equal to new set. And you understand why we're using sets in a minute. Okay, so instead of this, inside of this broadcast message, we take a message as a parameter, message. Then inside of this client, first of all, once a client add and we check if there's no errors, we say client add WS. And the reason why we're using set because so that we will not add clients twice. Once there's a connection and the connection is not lost and the person sends a message for the second time, we don't want to add the person again. The set, we only add unique value in a set. So the client is already in our database. So we just leave it like that without adding the client again. So now we have a broadcast function that we use to broadcast the message sent by a single client to the rest of the clients. So how do we go about doing this? Okay, the way we go about doing this is we'll check the client that sent the message. You see client, that's for each client, what we want to do is, instead of this callback function, we'll say if client, that's if the message sender is not equal to the receiver. If the message sender is not equal to the receiver and the client ready state is exactly equal to WebSocket open. If the ready state is, if the state of the client is open, what you want to do is, we want to say client send message. These are WebSocket methods. The ready state. The ready state may be closing, closed, or if the connection is closed, the ready state is closed. If it's closing, the ready state becomes closing. Or if it's open, the ready state becomes open. So if the client is not, the receiver is not equal to the sender, and the client ready state is open, what we want to do is we want to broadcast this message, but not to the sender. we want to broadcast it to the rest of the clients, not actually to the sender, because the sender is sending the message, so he doesn't need the message. We want to broadcast it to the rest of the clients. So this is exactly what this function is doing. And then we say inside of this message, we'll log the message to the console, then we'll broadcast our message. The message we pass in as the parameter, we'll supply it now as an argument, so that this message will be sent to the rest of the clients. So let's come back to our clients here and do something like hello. You can see hello. Okay, and I think it should work now. If it doesn't work, I don't know what's wrong. Hello. See hello. And we are seeing object HTML input elements because we are supposed to see hello. And I think the mistake is somewhere on our client. Because actually what I want to do here is, if a sender sends a message, I want the message to appear to them. It's just like a chat application. So if a sender sends a message, the message will appear to them and it will appear also to the receiver. So chat div inner HTML, chat div inner HTML, message. Okay. Even data text, and then text. Okay, so the error must be from here. We're converting this blob message to text, and then grabbing the text, and then adding it to our chat dev elements here. We have a lot of paragraphs. The first chat will come in as a paragraph. The second chat will come in as a paragraph as well. But then what actually is happening that we're getting, what we're getting here is object HTML input element. Okay, so we're not getting a string, but an HTML input element. So why is that so? To text event data dot text dot then text chat element event data to inner HTML, this paragraph, the message. So what's wrong? Okay, log text. Let's log it to the console and see. Send a message. Hell, wow, hell. Let's come back here and see what we got. Okay, we're getting our message here as a string. Okay, this is supposed to be text and not message, text. We are good to go now. The error was from me. So let's try it once more. Testing chat app, send testing chat app. Come back here and to see our testing chat app. Test again. Test again. We'll open here and we see our test again. That is wonderful, instantaneously. We don't have to wait for anything. We are seeing our message, testing chat app, test again. And then what we want to do is, if the message is ours, if you are the sender of the message, we want our background color to be red. So that we differentiate between the incoming messages and the outgoing messages. So we say style is equal to, then we say background red, color white, and border radius of 5 px. Border radius, we want to make it more eye-catching. Border radius 5 px, and then padding of 2 px. Then what we do is we'll copy this whole thing, bring it down here, and change the background to blue. We come here and then we'll open more, copy this, paste it here. You see sender 1. You can see it's in red, sender 1. Open here, it's in blue. Let's see, sender 1. Because this is not the sender, it's the receiver. Another one here, sender 1. Okay, in here we say this is sender 3, send. It appears in red. This is incoming and this is outgoing. So the sender knows, oh, I'm sending the message in red. Then we'll open here. This one is receiving all the messages, sender 1 and sender 2, because this is actually sender 2, sender 1 and sender 3. And then if you come here, you see that this will have sender 1, then the sender 3 is not this sender. But if you come here and say, oh, this is sender 2, send, then come over here and see this one sent earlier, then sender 3 send, sender 2 send. If you come here, you will see that sender 1 send, sender 3 send, and then the sender 2, which is this very one sent, and then this one, sender 1, it's sent, and then this one. And you can see, hi, sender 1, how are you? You send like this, how are you? And then this one sees it because the message is referring to sender 1. Sender 1 sees it. See, oh, I am fine. What about you? And sender 2, you send. Oh, I am fine. What about you? And sender 2. So sender 2 is, well, I am fine too. I am fine too. Then sender 3 this one say, great. I'm fine. Can you see this? So it's just that, okay, this one is chatting. It's actually a group chat. And inside of this group chat, if the chat is incoming, it will be blue. But if it's outgoing, it's red. And then here as well, if it's incoming, it's blue. If it's outgoing, it is red. And here. So as you can see how interesting this is. And you can go ahead and do many other things like, okay, you want to check, you want to add this to a database, and everything, all the chats, the server is logging them. Oh, I am fine. What about you, sender 2? Well, I'm fine too. Great, I am fine. And sender 2, sender 1, the connection is actually, let me refresh this. Come down here. As you can see, connection closed because it noticed one of the clients went off. It went offline. So come over here and then see, oh, it seems sender 3 is offline. Then sender 1 will reply, yes, I noticed. Then you come down here, view, connection closed. Oh, it seems sender 3 is offline. Yes, I noticed too. Now we want to do something. If you come back here, this message appeared. You see, yes, I am back online. Send it. Come over here. Yes, I'm back online. Then refresh this one. Then come to the console and see connection closed because one person has gone offline and the connection has closed. And once the connection closes, you will see, if you view the server, once the connection closes, WS close, on close, log connection closed. If one of the clients, if one person goes offline, the connection between the server and that very client has closed. So you get this message, connection closed. And then we want to see client delete WS. We want to delete the client in our database, or let's say they are all active. We want to notify that, oh, this client is inactive. So we want to actually, because when they are connected, we added them. to our, let's see, our database. So once they go offline, we want to remove them. We want to actually delete them. So once they are offline, we remove them. But let's say from the group chats, when they're offline, we want to notify that, oh, this person is online, or let's say on connection. We want to say broadcast a user just connected. Let's see how this goes. Connection closed. Let's copy this. Bring it over here. Paste it. Then let's check in our console. Okay, so we're getting, yes, we're adding it here, broadcast, clients. Okay, an error on message. Oh, so we're not getting any. Oh, okay, let's just log the user just came online like this. Wow. How many do we have? We have 1, 2, 3. Let's practicalize this. Connection closed. Let's actually close all the connections and then come down here. Like this. Stop it, please, and open it again. You have to be in the HTML file. Go live. Okay, so now we're live. Let's check. The user just came online. Can you see how this works? Once, okay, now let's connect about 3 other clients and see what we've also got. Come here, copy this, paste, hit enter, and check the console. The user just came online. Paste again, hit enter, check the console. The user just came online. So now we understand better how all these chat apps work and the rest of those things, the streaming platforms like YouTube, you want to stream a video. And if you can notice, all of these are actually events. We're listening to the connection event, we're listening to the error event, and this is built in the WS library. These are using events. So instead of you to go back and start building all of these on your own, instead of you to go start building all of this on your own, you simply utilize the WS library to make use of this event. The connection event, the error event is here, the message event, and the close event. So all of these are being handled. And then if you come down to node modules, go to MS, WS, this library here. And then you open browser.js. Module export function, WS does not work in the browser. Browser client must use the WebSocket object. And look at the WebSocket object you are using to connect to the server. If this server is an HTTP server, you see something like, HTTP/://localhost. But this is a WS So we're using WS and not HTTP. Okay, so we are trying to see how this WS is open source and you can contribute to it. So if you don't know how to start contributing to open source projects, if you understand JavaScript very well and you are good at what you do, you come here and check. We have WebSocket which require like WebSocket. WebSocket creates WebSocket stream. Can you see the WebSocket streams? WebSocket server, create WebSocket server, WebSocket receiver and sender. Then we have WebSocket.WebSocket to go to WebSocket and then module export to WebSocket. I think when we were learning NodeJs, essentially we talked about exporting only the interface we want a user or other developers to interact with. As you can see, look at what is happening here. They don't want us to interact with all of this. What they want us to interact with is the WebSockets, only the WebSocket objects. So they're actually adding all of this to the WebSocket. They are requiring this, all of this, and then adding it to the WebSocket so that we can actually get access to it. And as you can see, the WebSocket server and the WebSocket, that is actually the reason why we are importing it like this. And we can see yes. And then here you can see new WS dots like this. And then down here we still have, I think that's all. Okay, our class, new WS. This is actually an object. You can remove this WebSocket from this WS. You can see once this is equal to WS. Then let's come here and see. Can you see the WebSocket server? And then you can actually the WebSocket as well. And then you remove this. Like so. Because the way it is being exported here, you can actually go to these third-party libraries. You can go there and see in the package.json, you can go and see what they're using. See RFC 6455 WebSocket read time, and all this repository, browser imports require, export browser.js import and package.json, the files, browser.js, the script. We have their own script here, peer dependencies, buffer util and UTF-8 validates. Peer dependencies and meta will have buffer util option are true. UTF-8 validate option are true. But if the option is for it is needed and it must be included. Then we have the development dependencies you can use in contributing. We have ESLint, buffer util benchmark, ESLint mocha, and the mocha is essentially used in testing. There we have preacher, and later on we'll see how we can utilize all of this. And these are the production dependencies, also known as the peer dependencies. And this is an open source project where the repository, the homepage, and all of that. You have wrapper NJS, create WebSocket stream. Then if you come to the lab, you have buffer utils. And in the buffer utils, everything is here. They've documented it. The mask source, mask output, offset length, for length, this one, that one. If you understand, this here is bit manipulation. This thing very simple. So this code, they are actually manipulating bits here. So if your JavaScript knowledge is not up to this, you have to go back and then learn. So this is how this library, we have constants, the GUID, empty buffer, buffer.allocate 0, and buffer is actually a space in memory. Let's say an array in memory, a space in memory that holds string. Before, if you type a text, if you type a string, before that string is written to disk, it is held in a buffer. So once you type it, it is held in a buffer. And once you hit in a programming language like C, it is held in a buffer. And once you hit enter, then that string is actually written to disk. So a buffer is actually it's a 256 255 plus the not terminating string. In C, you have to do something like name, this is a string, is equal to something like this. The name you want to write, and then you terminate it like this. How do they? I forgot it. Like this. This is a not terminating string. This is how to do it in C. Because if you don't terminate it, it is known as buffer over yeah, buffer overflow, something like that. It's a buffer overflow. I know be consistent in C these days. So all of these extensions, I'm just going through this to make you understand if in case you want to contribute to open source. And they all have rules. If you go to read their GitHub repo, you open an issue, and then they have steps that you follow. You describe your issue, why you're opening that issue, what do you want to contribute, what exactly is the problem that you want to solve. Then you state your problem or have the README MD. In the README MD here, WS is a simple to use, blazing fast and thoroughly tested WebSocket client and server implementation. Passes the quite extensive auto-bound test suite like this. You can come to their documentation or head over to their repo and then read all of this, or you open this. Install npm install ws, opt-in for performance. There are two optional modules that can be installed alongside with the WS. These modules are binary add-ons that improve the performance of certain operations. Pre-built binaries are available for the most popular platform, so you don't necessarily need to have a C++ compiler installed on your machine. So npm install does say optional buffer util allows to efficiently perform operations such as masking and unmasking data of payload, the WebSocket frames. npm install save optional UTF-8 validates allows to efficiently check if a message contains valid UTF-8. Okay, so that's great. I think that's all for WS. And in our next class, we've learned WebSockets, how WebSockets work, when to use WebSockets with HTTP, and we've practicalized how would this WebSocket work. But then we've not using WebSockets to build a project is a kind of a complex stuff. Then in our next class, we'll see how we can use the real-time chat applications, learn how to do real-time chat application with Socket.io, and how we can simplify the complexity of our WebSocket with Socket.io. And then with Socket.io, you can build applications. Socket.io actually utilizes WebSocket under the hood, and you can use it to build production-ready applications. So if you have any questions, you can go ahead and ask. If no questions, we'll actually call it a day, and then we'll meet again in our next class. Thank you.